Good morning, everybody here in the room and online. I hope you can hear me well. Also, the online participants. So, a warm welcome to this session on bio-based materials and their potential for the EU industry. My name is Maarit Nyman, and I work in the Commission in DG for Internal Market, Industry, Entrepreneurship and SME, so DG GROW. And my area of specialization is the bioeconomy. And I have, of course, today here with me very eminent specialist speakers who will participate and build this session up together with you. So before I go into all the, let's say, more technical details on how we see the session, let me just say a few words to set the scene. So today and during this hour that we have ahead of us, we will be diving in the very fantastic world of the bioeconomy. So bioeconomy meaning economy that uses biological resources, processes to produce materials, energy, and different products. And we have, of course, in the EU, a EU bioeconomy strategy, which gives a kind of a broad framework for all the actions that we are undertaking, so that we can make our economy more circular, more sustainable, and also more bio-based. And of course, we are in the industry days. The industry obviously has a key role in all these activities and to reach all these very ambitious objectives. As I said, so the title of this session is Bio-based materials. Well, what are bio-based materials? I'm sure that many of you are already familiar with what we are talking about when we talk about bio-based materials. But actually, we refer to all the renewable biological resources, like crops, like trees, even algae or waste, which can be used as input for different industries in different industrial sectors. And the idea why we want to really focus on bio-based materials today is the huge potential to help Europe achieve these big objectives. I mean, I'm sure that most of you participated in the introductory opening session, and you heard the speeches and the really important objectives and policy messages. So in this workshop, we try to understand how the bio-based materials could help Europe to reduce dependency on fossil-based raw materials, feedstocks, which very often are imported. And also, then, how can we strengthen the EU open strategic autonomy, make products more sustainable with a lower carbon footprint, and also, as was mentioned this morning, how can we at the same time strengthen the European industry's competitiveness and also create jobs in the European Union? So all these objectives are the topic of today's session. And what we want to show with this session is that actually this is already happening. So different industries are using bio-based materials to produce products, different types of products in different sectors. So it is already happening, and the potential is huge, as the speakers will tell you in a moment. And with this session, we also want to raise awareness of this potential, of the future developments, the need to do more of cross-industry cooperation, really drive forward the bio-based materials, bio-based industries. And then, of course, we also want to understand what are the possibilities. I mean, this morning we heard about critical raw materials. Could we maybe think that we could substitute critical raw materials with bio-based materials? And then, of course, we also want to know today from the industry representatives that what can the European Union, what can public authorities, also in member states, regional level, do better to create a better environment for companies to operate and kind of help us to shift towards bioeconomy or bio-based economy in the European Union. So our speakers, I will just very quickly present our speakers today. So Liisa, first, I mean on my right-hand side, so Liisa Maltagliati from Stora Enso, then Lydia Garcia from Technopackaging, then Alexandra Lobnik from IOS, and then finally Mikael Mügge from Susvert, who so all speakers will present what they are doing, and the idea is that we cover really, I mean, very different sectors, industry sectors, from batteries, packaging, fertilizers, textiles, and showcase you what is the potential of bio-based materials and how the bio-based materials are currently used. So what I suggest as a structure for this session is that we have the 4 presentations at one go. And then I open the floor for questions. I mean, you of course here in the room you can ask questions, and then also we take questions from the online audience. So if this is okay for everybody, so I suggest that Liisa, you start. Okay. Please.
Let's see if this works. Oh, sorry, it's slow. You've seen some of the slides already now. There we go. Good morning, everybody. And first of all, thank you very much to the European Commission and the organisers and the Spanish presidency for inviting Stora Enso to be part of this very important set of conversations. My name is Liisa Maltagliati. I work for a company called Stora Enso. And for those of you who don't know Stora Enso, we are a leading provider of renewable materials across wood construction, packaging, and biomaterials. We are listed on the Finnish and the Swedish stock exchanges. We've got around 20,000+ employees globally, but most of those are in Europe. And today I'm going to talk to you about something that we call Lignode, which is a bio-based battery anode material. Hopefully that's moving.
Maybe try pointing the...
Oh, yeah. That's the direction it needs to go in. So in terms of what we're doing, we have a dedicated biomaterials innovation centre in Stockholm. And we have a lot of very clever colleagues who are constantly looking at how we do more with wood, but looking at wood on a more molecular level. So thinking about cellulose, hemicellulose, and lignin. And the thing that I'm going to talk about today focuses on lignin. Lignin is basically the glue in the tree. So it keeps the tree together. It's what makes it rigid. And it's also one of the most abundant sources of carbon in the world, in the natural world. It's also a byproduct from the pulping process. So traditionally, this comes out as a kind of a liquid when you're in the pulping process, and that has been burnt for energy. But through research and innovation, we find that we can now do a lot more. So that includes, for example, bioadhesives or bio-based glues, biobinders, which don't have the kind of toxic substances such as formaldehyde and isocyanates. So that's a really interesting area of development. But getting back to batteries, we can obviously also make this battery anode material. So that takes me on to the next slide, which is basically to explain, is to sort of come back to the question, how can bio-based materials help to address replacing critical raw materials? We all know that the EU aims to be carbon neutral by 2050 and reduce emissions by 55% by 2030. So a major condition for that is electrification. And electrification means that we'll need a lot more batteries. One of the most common battery types that we have today is a lithium-ion battery. And most lithium-ion batteries use graphite for the anode. And every battery has 2 electrodes, one positive, which is the cathode, one negative, which is the anode. So we're focusing on that negative anode side. So basically, as I say, we can take lignin from this side stream, from a byproduct, and we can turn it into a hard carbon powder, which looks like this. And then at that stage, that's where it sort of replaces the graphite. You can use the lignode to coat a copper foil, which then goes into lithium-ion cells, and then it goes into the sort of battery value chain. So that's where we are. I think it's also worth noting that obviously we're looking at lignode replacing graphite in lithium-ion batteries, but once you start to look at non-graphite and non-fossil options, it then opens up for wider battery chemistries. So at some point in the future, there might be different chemistries which, in their own right, use fewer or lower volumes of other critical raw materials. So there could be benefits there too. In terms of why we think lignode is a positive development and why it's good from a sustainability perspective, perhaps the most obvious point is that we're using something that's renewable. And if you look at graphite, obviously that's finite. Natural graphite is finite. Synthetic graphite is made from oil. It's fossil intensive. And both of those have a significant carbon footprint. We also have full transparency and chain of custody. We know where the wood comes from. It's certified. And we know the kind of the social and environmental conditions under which it was produced. And then finally, because lignin is a side stream, we're using something that exists already. It's an industrial byproduct. We're not using additional raw materials. And we're taking carbon that could have been burned and then binding it into a product which has a longer shelf life. And we think there's also a double benefit in that we're using a byproduct from an industrial side stream, and then we take that new product, the lignode, and we're supporting a transformational process, which is also part of being more sustainable, so supporting the green and digital transitions. Finally, thinking about how we reduce dependency on imports from third countries and on fossil materials, I think it's fairly simple. Most of the graphite comes from outside Europe, comes from very few countries, and if you account for processing, it comes mainly from one country, which is China. And obviously, there's a recognition now that having very limited sources of raw materials is something of a risk. So it's about de-risking. Even if that weren't an issue, there are also potential supply gaps. Demand is all the projections suggest that demand will exceed supply. And so, for example, the OECD has said graphite demand should go up, is expected to go up by around 25% by 2040. Yet between 2012 and 2019, production fell. So there will be a gap. So we think with lignin-based anode materials, we can start to build sustainable supply chains in Europe, work together as an industry, and that can go all the way from the sourcing through to use and reuse, and then ultimately recycling. And I will stop there because I can see that I'm taking up my minutes, and hopefully I can come back to the questions about what we can do to help the bioeconomy grow when we get to the discussion afterwards. So thank you for listening.
Thank you. Thank you very much, Lisa. So I think we can go on with Lydia. Lydia, please.
With this micro? Okay, perfect. So, yeah. So I'm Lydia Garcia. I'm the head of research at a small company called Tecnopackaging. We're a Spanish company located in the north of Spain, in Zaragoza. And we are basically working in the development of plastic products, basically new formulations of plastics in which we are introducing bio-based materials and recycled materials. Then we study how we transform and we manufacture with these materials to obtain a final product. And you will see some examples there. We are working quite a lot in the circular bioeconomy concept, because when we are designing these materials or the final products, we not only think in the type of feedstocks and materials we are using in the first stage, which is essential in this case for decarbonization, but we need to think also in the end of life. So in the sectors in which we are mainly focused, we work quite a lot for the packaging sector, but also for agricultural applications and some other industrial ones, but basically those two. And we need to think if we will need a product that will need biodegradable behavior, compostable behavior, or just a good recycling, full recycling behavior. So those are critical points in which we are working. Okay, so you can see here what type of materials we are using as feedstocks. Basically, we work with material providers as polymer building blocks or polymer resins, but that basically are working in second-generation sugars. That's what we call to derive byproducts, for example, coming from food sector, but that are wasted, okay, or byproducts of, for example, juice production, or for example, that they are using cooked oils that from the Oreca sector that has to be retired from them. So those are very good starting materials, very good materials that we can start working. Of course, in Europe we have forest, and we have seen the presentation of Lisa. So we have those sorts of lignin, of cellulose, semicellulose, which are used, and also some type of natural plants that are very rich in sugars, or are very rich in certain kind of lipids that are very good starting points to develop new polymers, new bio-based polymers. And then, of course, sometimes we are looking for extra functional behaviors, let's say, for certain applications. So many times we are using, for example, reinforcing agents, and in this case we may use fibers, natural fibers, and depending on the place, the idea is to use the resources of a located area. I mean, we don't have to necessarily import or use resources that are not from your area. So, for example, we have developed some type of bags in which we are using for the Canary Islands fibers coming from the banana trees because they produce banana. But for example, in Slovenia, we are using fibers coming from hops. So it depends very much the resources that we use in each region and that we may have. For example, here in Spain, we are using a lot the reinforcing from the almond shells. They also have a lot of potential in the mechanical, for example, reinforcement aspects, but also in other antiseptical behavior. We are using wool from sheep, for example, for many applications. There is very good thermal and noise isolating agent. Or, for example, we are starting to introduce chitin or keratin as well, coming from seafood wastes, or from even insect wastes, or from even the same wool of the sheep. If you go for a more chemical process, you can extract some kind of high functional additives that will confer very interesting applications in the end, very interesting behavior for the materials. So this is the type of materials we are working with, and here I have some few examples of what we are doing. First of all, everything starts with the formula, let's say, where we blend everything in what we call the pellets, okay, or the compound, which is like the starting point of material that we need to go to any other machine or any other manufacturing technology that we will require to give like the final shape, okay? Then we can go for an injection molding for a casting and obtain a tray for meat, a tray for vegetables, a bag for other application. For example, we see here some of our bags for the agricultural applications. In our region, it's very typical to protect the peach or the pear or the apple. So it's something that it's very interesting that it's, for example, biodegradable in soil. So this is something that agriculturists are now looking for. But we have also developed jars for cosmetic applications. We have worked together with a very big juice company that wanted to valorize their own residues and to make the packaging based from their own residues, let's say, to package their own juice and then commercialize it. So there's a lot of potential applications in the plastic sector and the packaging sector. And I think that will I'm just saying that this would never have been possible without the help of the European Commission. We started in 2010, boosted by the ITIP Technology Center, and there were 3 passionate researchers based on the polymers field and the agricultural and packaging field, and now we are 43 people working on this with a very strong R&D department, and we have learned a lot from participating in the European projects from we started up to now, and building as well a network of clients, of providers, of understanding the behaviors of each region in Europe. So it's been essential to participate and to learn from this, to be able to launch the circular bioeconomy into the market. And thank you very much.
Thank you very much, Lydia. Then I suggest that we continue. So Alexandra, please.
I will sit here,
yes.
yes. Thank you for this invitation. We are really pleased to be here. I hope my presentation will start. Okay, I'm Alexandra Lovnik, coming from the University of Maribor as well. I'm the co-owner and of the IOS company, which is a research and development company established in 2006. So we are interested in various sectors. So we are not dealing only with recycling technologies, but also we are developing sensors and new novel nanomaterials. Nanomaterials we are using for sensor development as well for the recycling processes. For sensors to gain much more sensitive, selective sensors, and for recycling we are using adsorbent materials which remove very selectively rare earth materials or other metals. We have already a prototype of the adsorbent materials which can remove critical raw materials, and we can of course desorb them and use them again. I will not talk about this kind of the projects today, but I will focus on the recycling of textiles and plastics. We should be all aware that if we will not act in the recycling technologies more sustainable, in 2050 we will have more plastics in the sea than the fish. This is really critical moment. We have more than 75 million tons of textile waste annually. Only few percentages of those are recycled. Most of the textile is sent to the landfills and burned. This is the reality at the moment. So, therefore, we started with the first European project already in 2015. It was called Resintex. IOS was the technical coordinator. I was as well technical coordinator of the project. The Resintex was in the Resintex there were involved more than 20 partners, and we started completely novel technologies for chemical recycling of the textiles. You know there are existing already mechanical recycling technologies, but they are not sustainable because you can't go for infinitive recycling processes by using mechanical recycling processes. Therefore, our focus is on chemical recycling. This year, we continue with the Resintex approach, and we gain EIC project, Open Loop, where we are now paid from European Commission to optimize all the processes dealing with the textile recycling and to scale up to the industrial level. So we are dealing with various textile materials. You know, you have natural textile like wool, cellulose, and you have, of course, plastic and their blends. It's quite complicated, but we can already move to next level, to the industrial, also by pre-treatment processes, not only by chemical recycling. What we are gaining from each of the materials. From the wool, we can gain proteins and they can be used instead of the formaldehyde. We hear already today that we can use also lignin for that. So this is very important. Why? Because the formaldehyde, it's very toxic. It is known it's carcinogenic material. So it's very important that we remove all the toxic materials out of our products. So this is very good example how we can change the approach. Then we can go for cotton, cellulose. They are mostly used in textile. If we are solving the problem of the cotton and polyester, we are solving more than 90% of all the textile waste. This is very important information. From cellulose, we are gaining glucose. And from glucose, we have different possibilities to get different kind of products. From the energy, from the hydrogen, to non-fossil based chemicals with very high added value, like furfural, they're used for bio-based plastics now. Very important and very expensive chemicals on the market at the moment. I mentioned already that we are dealing also with the synthetic fibers, like polyamide, polyester, and we are converting them to the basic chemicals, which can be used, of course, for new textiles, or we can use them for new plastics, or we can use also plastic waste, and we are gaining materials to produce new textiles or new plastics. So depends what is your economics and what is your uptake. We built up in 2019 the first demo pilot plant dealing with more than 30 tons of textiles and plastics per year. Most of the chemicals are uptaken at the moment by Slovenian companies like Helios and others. But, of course, we are interested to scale up those processes in the next 2 years to industrialize in the first stage polyester and in the next stage cellulose line to complete this line and to have possibility to go for textile waste in very high quantities. And on the other hand, as I mentioned, we can also deal with the plastics. So I can say that IOS, it's now with this open loop project on the mission to change the perception of the waste recycling. So waste is becoming very important, and to, of course, to change the problems into opportunities. Thank you.
Thank you very much, Alexandra. So then, last but not least, certainly, Mikael, please.
Thank you very much, and thank you to the European Commission for allowing me to share with you some of the innovations that we've been working on Sasfert specifically. So I'm Mikael Mügge. I am Senior Manager at RTDS. We are probably the leading non-profit SME in Austria dealing with research and innovation projects in the Horizon framework. Before I start my presentation, I want to show you a quick demonstration of one of the products that we've been working on. And it comes on the topic of lignin. So what we've got here is a whole new generation of fertilizer solutions. So these are lignin, it's lignosulfonate. And I will just basically fill this with some water, and then we'll all see what happens with this during the presentation. Give this a quick stir. Excellent. So, quick introduction to Sasfert. So it's a BBI-JU project, 6.5 million plus euro funded, finishing in December this year, where we've been looking at a number of solutions, namely multifunctional fertilizers for phosphorus and iron supply, combining biodegradable coatings for controlled slow release. We're integrating probiotics, microorganisms for better nutrient availability, and we use all these things with renewable, sustainable sources, ultimately in the form of Nutrigels. So the impacts, and we're actually showing some of these things today, and I've got 3 prototypes on the table here which demonstrate all of them. So the aim of SUSVERT was to decrease the dependency on mined phosphorus that comes from Northern Africa, a lot of that. The aim was to reduce that by 40%. It's a very ambitious goal. We're using some of the products, and I'll show you the impacts of those that has been shown that we can possibly achieve that. We want to strengthen the bioeconomy by valorizing waste and byproducts. We want to act as a soil improving capacity, reduce soil contamination, also the frequency of fertilizer applications, increase the water holding capacity, controlled nutrient release, and we want to demonstrate these green technologies together. So how do we do that? We've come up with something, we call them SAS kits. So there are 9 prototype solutions here. Today I'm going to be focusing on 3 of them, namely struvite. So struvite is a phosphorus replacement. It comes from wastewater. I'll show you in a minute. So here you've got a prototype of struvite. We'll look at coatings, which are made from lignosulfonates, and then how we turn that into Nutrigels. And I'll be quickly going through kind of the next few slides in terms of net impact. So what we do here is we take SUSVERT, the innovation, and we take away the business as usual. So the kind of the common and conventional products that we're dealing with. So on the struvite, so as I mentioned, it's a renewable P source. It's available everywhere, and particularly in wastewaters. We have potato industry, we have dairies, manures, where we can extract the struvite from. So we have shown now that we can actually have a net positive effect by integrating and replacing struvite. And great news is that Ostara, it's one of the producers in Belgium for struvite, is just going through a certification to provide 100% struvite product as a fertilizer in agriculture. So struvite is simply a full phosphorus rock replacement. We use it in turf landscape, part of our sports field, golf courses, etc. You can see the middle picture here, a root analysis replacing SSP, single superphosphate, by struvite, 100% replacement. And you can see the crops here from growers' practice, no fertilizer, and struvite at least has the same efficacy as the farmer's practice. So what does that mean in terms of if we look at CO2 impact on global warming? So it's all very complicated, but I've tried to really put a simplified look at this. So anything that's up, in this case, is negative. So that's the kind of the production of, in this case, single superphosphate. That would then, if we look at that, split between sodium hydroxide, some magnesium sulfate, and the electricity for the production. Now I then look at, if I don't use that, then I deduct the single superphosphate, iron 3 chloride, and I add on top, of course, the struvite production. So with this simple, very simple look on it, I have a net impact of approximately 100% for global warming by replacing struvite, by taking struvite instead of phosphorus rock. The next we're looking at is bio-based controlled coatings. So what I've got here is I've actually got struvite, and this is coated with lignosulfonates. So lignin, we heard from before from the presentation, has many facets and many advantages. So we've coated the struvite here, which is a slow release fertilizer by itself. We've coated it with probiotics, microorganisms, and lignosulfonates for slow efficient release, fully biological, also acts as an anti-dusting. So if we look at the solution here, if I take the coatings, if I use the lignosulfonates, I get rid of a lot of polyurethane. I have a little bit of a wood chip impact. I take away the production of a commercial polymer coating that is used for fertilizer businesses at the moment, and then by reducing the input here, I can land up at a net impact of approximately 60% savings on CO2. Then finally, to the game changer that I want to present briefly in the few seconds that remain. It's our Nutrigels. So you saw the little demonstration earlier. So this is what we started with. These lignosulfonates. This is actually NPK, so it's a common fertilizer that we've coated and blended with the Nutrigels, and a couple minutes later, actually, it's absorbed into the water. So this is now, will last weeks until it dries up and will turn back into that. So this acts as a water absorption and a slow release of the fertilizer technology. So what's the potential of this? We think it's huge. So apart from the plants, this is a plant that hasn't been watered in a couple of days. We've also done a number of field trials throughout Europe. I've chosen some examples that are close to here. I think the first one, the pairs are in Almeria. So we have agrobiogels, the hydrogels in the control. But we've also looked at reducing the irrigation. So these Nutrigels can save irrigation. So we have actually reduced irrigation by 70% using these gels. So what we do, we create the rows, we fill the rows with Nutrigels, and then we cover it up again. And I think the most compelling is the almonds on the right here, where you see the control and then 100 grams per square meter of Nutrigels introduced into the growing. So this has, of course, a phenomenal impact. Also, particularly, we look at this slightly different, but in terms of saving irrigation. So we have, of course, electricity and gas, pumping and all that kind of stuff, but we have a phenomenal result using and introducing the Nutrigels to save irrigation. So Susvert has been going for a while now. This basil, we all know the problem of having basil at home. It either lacks water or has too much of it. This basil has not had any water for 14 days, and that's how it looks. So 14 days no water. We have 3 months to go for the project. So thank you very much, and I hope to stay in touch. Thanks.
Thank you. Thank you very much to all of you for these very interesting presentations. And I think that they showcased really well the diversity of different raw materials, feedstocks, the possible applications, how they can be used in different industries, and all the future potential, and also the concrete impact that these new technologies, materials, and applications can have. Also in areas like Mikael was explaining, like that will have an impact on food security and securing access to food to everybody. So I think very interesting examples. Before we go into the questions part of this session, from my side I want to just add, I was mentioning the EU bioeconomy strategy in the beginning, and when I was following the presentations, of course, colleagues were also referring to different projects that are financed by EU funds. For example, Alexandra was referring to Horizon Europe funding to European Innovation Councils, which supports breakthrough innovation. So that's important to note. And then also, Mikael, in your presentation, you were referring to the bio-based industries joint undertaking, whose work, it's a public-private partnership between the Commission and then the industries, bio-based industries, and now its successor Circular Bio-based Europe is doing also groundbreaking work in financing different projects where you try to find bio-based materials that has the potential to replace fossil-based materials, but not only that, also looking through the whole value chains and trying to build these value chains, bio-based value chains, and also looking into ways how to accelerate the market uptake of different bio-based products and materials in different industry sectors. So now I would give the floor to you, participants here in the room, but also online. So any questions that you have to any of our eminent speakers, or any comments? Please introduce yourself before you ask your question. So, Bernard, please. I think we have a...
I think we might need to give another...
Yes, you need a microphone.
There you go, all part of the service.
Yes.
Thank you very much. Working?
Okay.
Okay. I wish it works. I'm Bernard de Galambert. I'm working for Cefic, the chemical industry, but my scope is bio-based chemistry. Fascinating presentations, I must say. I'm wondering if I'm in the innovation days or the industry days, because it's all indeed very innovative presentations. But moving to the industry days, I have one question to basically all of you, and it has to do with the economics. I mean, it's all indeed fascinating, but to what extent does it compete, each of your innovation, with the current, let's say, fossil alternatives, price-wise, cost-wise, and what would it take if you wanted to really grow on the markets in Europe? What would be, from your perspective, the needs to boost the uptake of your products? Thank you.
Thank you. Well, please, Lisa.
So I think that's a really good question, and you're right. It links the innovation, sort of research, and side to industry and commercialization, and it also brings us back to the question about what can the EU do to help, what can the Commission do to help, and I think. One of the challenges that we have is that we're in a system that's been designed around the economic system. We have a sort of a regulatory framework that is designed around the system that we have and have had for a long time, which is fossil-based. So that doesn't always work, and we're trying to compete, bringing in new products and cost, and breaking into those markets is challenging. So I think one of the key things for us is having a framework, a regulatory framework that thinks about the future, that is what we'd call enabling. And sometimes that might be something that's very horizontal. Sometimes it might be something that's quite specific. So, for example, we've seen, if I talk from a batteries perspective and a new battery material, we can see that in the batteries regulation, there'll now be a batteries passport, which will have to include a lot of information, including the share of renewable content. So that's something that sends a signal to the market, even if it's not a target. It's something that sends a signal. And equally, we would say, for example, with the Critical Raw Materials Act, that given that we have something that can replace a material that is on that list of critical and strategic raw materials, if you have a substitute material that can do the same job, it's a means to an end. It's about enabling the technologies that we need for the green transition. Sort of treating those materials on an equal footing is another way to sort of enable that market to grow. So that's sort of one thing that I would suggest. And then also, I think there's something around de-risking the finance, but we can come back to that.
Can I add something? So we know already that terephthalic acid, for instance, coming from polyester, it's more expensive than a fossil-based one. And this is critical moment. So how much it's the uptake industry willing to pay for secondary raw materials? This is also the question. 10, 20% more, or the prices should be the same. So this is also something where we have to be very clear, because secondary raw materials are more expensive.
Any other?
Okay. So I like your question very much, because I deal with that question myself on a permanent basis. So on the example of what we're doing here, we actually have selected 9 prototype products, and I'm delighted to say that last week, together with industry partners in our board, we have put forward 7 of them for commercial application. So I'm not saying that all of them will make a success, but I'll just take an example. So one of our prototype solutions is a commercial bio-based fertilizer on the market, which we have blended with our hydrogels. So that's very simple. It's salt and pepper, okay, put together, and the meal tastes better. So what it also does in this case, this acts as a drought insurance. So we have shown that we can prevent and create a drought insurance de facto of 12, 14 days extra survival for the plant by using and integrating these hydrogels. So that's for sure worth something. So we might not be able to match the price, but we have other benefits that surpass the conventional products.
Lastly, to add something that's In our case, it's clear that for the plastic products, if you try to compete with fossil-based, they are a little bit more expensive, okay? But at the same time, we have to say that these materials are starting to decrease, that with the COVID there was a higher cost. It was quite difficult to even purchase commercial polyolefins, or PET for production. So once these bio-based materials are in the loop of a circular bioeconomic concept of we need to recycle them in the food contact sector, the EFSA needs to certify the recyclability of all these technologies. And what we are finding is that in 2030, we will need to include a 30% of recycled material, even if it's bio-based or not, into any product, any packaging product. And the issue is that there are no flows of these recycled materials because of the washing, cleaning steps that are a challenge still for the recycling companies. It is true that we can go through this chemical recycling, but it's energy consuming and it will increase the cost anyway. So we still, the general cost for any material in this loop would increase. So once we are able to introduce these bio-based materials, I think that in a few years we are not going to see that different in cost, and we are going to bring other benefits, as we are saying, in the use of own resources from local areas, avoiding to import. We are now starting to have higher taxes for this recycling, in the packaging sectors in particular. So probably we'll have some tax discounts or incentives to use as well these bio-based and recycled materials. So in the end, we are seeing that they are starting to level up a little bit, and it's starting to be easier to introduce them in the market.
Good, thank you. We have one question from online if I can get it on the screen. So it was a...
Here we go.
Yes. Yes. Yes, exactly. So it's Lisa for you for this. So is your product already commercial? And did you have any issues getting approval, especially for the automotive sector?
So it's in the process now of we're at the pilot stage now, so we have a pilot plant which is producing and working with partners and customers. Some of those are public, some are not. In terms of approval, I know that it's passed all the relevant tests in terms of sustainability and substance classification and so on. So really we're now at the stage where we want to get to the point of actually building a plant, and that will be the next step. So I think, in the current climate, there are plenty of challenges, but that's where we go next. So for now, we're working with our potential and partners and customers, testing the product, testing the process, because one of the benefits of what we have, it can either be a replacement 100%, or it can be blended with graphite, depending on what actual performance different customers want. So there's a lot of different options being explored at the moment. So not yet commercial, hopefully not before, it will be commercial before too long.
Okay, good, thank you. Are there any more questions from the room? I think, yes, please. Sorry, we can't hear.
It's on? Yes.
Yes.
Okay. Thank you for all the interesting presentations. My name is Paolo Sarsama. I come from the Infinited Fiber Company in Finland. We're a chemical recycling company. My question is for Alexandra. You were mentioning textiles to chemicals, and I'm interested in the polyester and cotton fragments you were speaking of. Can you work with mixes, and what kind of mixes can you work with?
We are working also with blends, polyester, cotton. We are using two different approaches. One is chemical degradation, and for cellulose, enzymatic one. so we are able to really to purify each of the materials. You're welcome.
Good. Then, please.
Thank you. My name is Stijn Sante. I'm standing here as chairman of the Projects Network for the Zero Emission Platform. I have a question for DG GROW, and I was wondering whether, besides all these fantastic innovations, there's also attention for the development of biogas in the European Union as a way to get less dependent on the import of natural gas from outside Europe.
Good. So thank you for your question. In DG GROW, I mean, our main focus is on biomaterials. So we work mainly in that field. But of course, I mean, our colleagues who work on energy policies and on energy, including biogas, are looking more into these aspects. Sorry?
So is that your colleagues in DG GROW, or is this topic biogas in DG ENER?
In DG Energy, but of course we do cooperate closely, and of course issues like biomass availability for different uses. I mean, we are talking now about on material use, but of course you also use bio-based feedstocks for energy production. So it's also a kind of in a big picture. It's important that we understand which part of the biomass use goes to biofuels, which goes to materials use production. So in that sense, of course, there is cooperation. So we are kind of part of the same picture, if I may say so.
Okay, thank you. I've got more questions, but it's probably outside the scope of this meeting, but
Yes.
if you're willing to discuss it later. Thank you.
Are there... yes, please.
Thank you. My name is Francisco Rodriguez from Banco Sabadell, Spanish bank. I was wondering, are you having easy is it easy to finance your projects? Are you finding it easy? And what would be your main financial sources? I know Stora Enso is a big company, so probably they go into the market. But the rest, I would like to know a little bit more about that. If it's easy for you to get the financing, and what is the main financial sources you're finding? Thank you.
Yes, please.
For us, it's that we are really supporting by ourselves also the research. This means also if we will not get this support from European Commission, we will go with those research and development. This was our focus and vision already before we gain any of the grants. So this is, I think, very important. If you decided that this is vision, you are not really researching because of the project, but you are starting the research and you are supporting this also if you have no money. And we are also taking bank loans for research. So we are really have strategy and vision. And we say those projects we will support, and then we will see if we will gain also some support from European Commission or others. But for recycling of textile, recycling of plastics, we feel that this is very urgent issue. So we already worked on that after Resintex before we gain another grant by ourselves. But of course, with European Commission and with all those grants, you are pushing much more the research. You are faster, and probably we can realize faster all those products and technologies. Without that, probably we need some more time. So this is beneficial. But we are supporting by ourselves.
Yes, thank you. I put a question that we got from online. Would you be successful without EU funding? But you, of course, already partly answered to that question. But any other ideas from the panelists on the role of EU funding?
Answer him or to this other question?
Yes. Answer
Okay.
him,
Oh, yeah.
but,
Okay. Sorry, I thought that we weren't finished. In our case, it's also a kind of a mix of things as well. The research and development department, we are talking about lower TRL projects, more niche ones. Then we are working or participating in this kind of more European or national projects, so to get these funds. But once we start upscaling and going in through the market, the investments, we have loans with banks, of course. And also many times we are looking for particular partners, big companies, in which we make a kind of temporal association and we bring together and we co-finance the final product, let's say. So we are doing, with several products, we are doing that approach as well.
I mean, I second that, or third it, or fourth it. So we clearly would not be successful without EU funding. So the components that we have here, no one company has those solutions. So there's 14 partners with expertise that do collaborative research. The challenge here is to turn that research into innovation and these results into opportunities and impact. And so it's really how you put the consortium together, that you have the whole value chain in the bioeconomy, and we're grateful that we have solid partners, leading partners in their various fields, and hence the uptake potential of 7 out of the 9 prototypes that industry will carry on forward. Otherwise, I agree, there's often this term, the valley of death. What happens when the project is over and everybody turns off the light? In this case, the light will continue to shine.
And I think even for big companies, obviously, even if we have our own in-house innovation and research and we come up with our own innovations, I think EU funding can still be extremely helpful. And we're looking at things like, the Innovation Fund, and obviously there's Horizon. But I think, quite often then it's the valley of death. And sort of the scale-up phase, and it's that gap. So there's lots of money available for the research and the innovation, and to get the ideas, together and to develop those and maybe test them. But then it's taking that next step. So I think there are a lot of conversations to be had around how you de-risk that phase of the scale-up. And in a way, one of the speakers alluded to that this morning. That if you've got you're going to build a brand new plant to do whatever it is, you get the permits, but then you need a long time to pay that back. So how do you at least de-risk some of that investment? So I think there's a conversation around that.
Good, thank you. Any other questions? I think we are very close to the end of the session. So what I would suggest, thank you very much, first of all, for all your questions, also for the online audience for their questions. To kind of wrap up and think about the takeaways from this short session. I would leave the floor first to the speakers. What do you take from today's session?
I take away the fact that there are some really exciting different innovations across the whole bioeconomy, and I think that diversity, something that you said, Lydia, about you use different resources based on where you are and what you have available locally. I think that's a really interesting point, and we should build on that diversity. And it means that one phrase that we use quite often in the forest industry is that there are no one-size-fits-all solutions, because forests are very different, all around Europe, even within a country or within a region. So I guess the same with other kinds of resources as well. And the other thing I take away is, that it's great to have this kind of opportunity to discuss things. So thank you.
Thank you. I think that we have shown here with the various projects and innovations that efficacy is possible, and we've shown that in the various products. And now I guess we are on the step of having this possibility to replace conventional products. So I guess what we need to do is we need to focus our research jointly on a collaborative effort and drive this impact forward, because it's all here. And ultimately regulation is coming. Whether it's not in place now, it will impact all these conventional products. So the only way is forward, and together we can do this.
Yeah, really.
In our case, I think that the industry is doing a great job, is doing a great effort at all levels, large companies, small SMEs companies, and RTOs, universities. I mean, in the end, we are all going together to put all these feedstock, natural feedstock and resources that we have in Europe in the market. We are succeeding on it. I mean, we see the products that are in the market. For me, there is still some room for improvement that I think that we will achieve it in the coming years in the recycling part of these materials. And that it's the opportunity that we have to work now in the end of life, to keep on working, in our case, in the recyclability of these bio-based materials, to make us succeed and to see them in the market at mass level, let's say, in the coming years.
I was thinking by listening all the presentation that the circularity, sustainability, it's not anymore only nice phrases. They are nice phrases, but we are really supporting basic researches to the first commercializations. So I think this is very important. Before 2-3 years, we start with ideas of circularity, and they were only words, but now this is becoming real, and this is important. And this is also because the European Commission is supporting the projects, very pushing the circularity and sustainability forward.
Yes, thank you very much. I mean, my takeaways definitely are that I see that it's all here already, as I think Mikael said, and you, Alexandra, echoed the message that it's happening. And of course, our role as the European Commission is really to now see what we can do, to kind of accelerate and ease the process and kind of path for your businesses, and also of course see and try to promote this cross-industry dialogue and cross-industry cooperation, because it opens up a lot of new possibilities, and we got already, I mean, during this very short 1-hour session, good messages relating to feedstock, need to scale up processes, bio-based processes, and all that. So that's definitely something that I take away from my side. So thank you very much for all the speakers. Thank you for you who are in the room for coming here, and also thank you for thanks to all the online participants. Thank you.
Thank you.